right? So here we are actually trying to get some work done on Friday. In terms of learning, we have a bunch of people here who are at work in the community at the moment. It's a good thing you can't read their chat right now because we've been having crazy water cooler talk for like 15 minutes or so. So if you haven't, I'm just going to put a plug. If you haven't joined our community here on Twitch, come on in. Most of it is not suitable for work, so I can't repeat. My channel is rated M, and I will occasionally say fuck. So, oops, I think YouTube's going to get mad at me. I said that within the first 5 minutes. You're not supposed to do that. Sort of serious mode engaged. Exactly. It's my sort of serious mode right now. So, we've already burned up a lot of our Kubernetes Colearning time. So, and I'm going to get my run in today at 1. By the way, I am now IRL streaming. So if you want to go running or talk about tech while we're running and walking, all of that jazz, I'm doing more of the variety streaming stuff. So come on in, mostly because it's just fun and I'm lonely. My wife is so busy right now. She's been doing like murals and art galleries and all kinds of stuff. So I have a lot of time to stream. What was I going to say? Oh, I wanted to tell you I'm going to change tonight. So if you're here for the schedule, I've been doing Kubernetes Colearning Friday and Saturdays, 10:30 or so on. I am actually going to. I put CAD Colearning on Saturday. I'm going to try to keep that. One of the problems I'm having right now is that I have a lot to do with regard to this house and cleaning up, stuff like that. So that's not on the stream. I don't know if I'm going to be able to get to the Kubernetes Colearning tonight or not. At this moment, though, I think I'm going to go ahead and leave this here. If I get rid of it and I try to fill it with even building out the cluster is considered Kubernetes Colearning. So even if I go IRL and I'm like walking around, like setting up computers and stuff, that will still count as Kubernetes Colearning. I just don't want to get pulled down too much into that. I do have a lot of like IRL work, organizing computers and networks and stuff to do the Kubernetes Colearning for that. So that's kind of where I'm at right now. There are a couple like real high priorities of work right now that I need to focus on today. And so I'm going to write out what those are. I neglected to make a Zettelcast for this, so I'll just go ahead and do a note. So which is that create Kubernetes Colearning. Co-learning. So we'll just do this one for right now. And so today, so we're still working on the Elasticsearch install and how to do that and how to simulate that installation. So that's actually one of the biggest things I need to work on. So again, this weekend it'll be a lot of Elasticsearch installation and setup. I'm starting to not like the application, but whatever. Something else we need to do is I want to talk about how to do check deployments, check Helm deployments, deploys for OPA Gatekeeper policy constraints, policy compliance. So this is somewhat related to work. So these are the two main things. And it's going to probably take most of the day today. So I don't know. My sleep schedule's all being messed up again now too. So I'm actually going back to kind of, I don't know. We'll see how the sleep schedule works out. You guys know I'm sort of doing a dual. So these are two really big things that are kind of on our docket right now. I've been kind of put in charge of doing a production systems applications audit, systems namespace audit. And I'm going through and I created a YAML document to document all of our existing applications. What are they doing? Our cron jobs, all this stuff. And we are I don't know how much I can say about it, but we are moving away from our automation layer. So And that's actually something that I don't feel is proprietary to share. I think it's fine for me to tell you. So we are moving away from homegrown, um, uh, from homegrown Helm wrapper for a lot of reasons. And I kind of want to talk about that first. So let's just do this because this is actually really important right now. Um, and let me set this up for you. So we have probably some 30 or 40 production namespaces, maybe less than that, maybe something like 20, maybe. And what they are, you know, in our particular case, we have a label that I won't say, which would probably be proprietary. And we check that label. And if the label is a certain thing, then, you know, it's something that we maintain. So this is kind of a thing. So in the normal course of a life of a Kubernetes cluster, so, you know, it's like there's kind of a collection of system, if you want to call them infrastructure or infra, you can name them whatever, namespaces, namespace apps / applications, whatever you want to call them. So as you know, Kubernetes, the way it works, Kubernetes is, you know, it's this monstrous collection of nodes, which are machines, and then there's a bunch of work that goes on those things. Ultimately, the work all comes down to a pod, which is a container with primarily one container. Sometimes it has a sidecar or something, but almost always a pod is the exact equivalent of a container, almost always. So just think of pod equals container for the most part. And those containers are running all over the place because Kubernetes is an orchestration framework. And, you know, this explanation to you is helping me to be able to explain it to myself as well. So don't consider it a loss of time or anything. And so that's what Kubernetes is. It's taking care of all these containers, making sure they run, that they stay up. And there's lots of different ways you can do, lots of different types of things you can do in a container. You can have a cron job, and it's just confusing, by the way, because it's called a cron job, and we have also Unix cron jobs and Linux cron jobs. So, you know, we have to kind of disambiguate that when we talk about it. It's like, oh, we need a cron job for that. Like, what are you talking about? Do you want a Linux cron job or do you want a Kubernetes cron job? Because it's the same name. So we have cron jobs that run at regular intervals. We have jobs that just run once. And these are all Kubernetes resources, by the way. These are all standard Kubernetes resources. Kubernetes gets confusing because you can extend the type of resource. You can create your own custom resource definitions, and it can get really messy really quickly. And they're called CJs. You call them CJs, okay. But they're important, right? So the idea of a job and a cron job, when it comes to infrastructure namespace apps, is super important. So what is that? So first of all, you're managing this cluster for your enterprise for one purpose, right? You want people to run what they need in whatever way they need, quickly and easily, and provide this infrastructure for them. That's, you know, the turnkey idea of declarative, you know, orchestration. And then all they have to do is create deployments, and then in their user application namespace, they just you know, put a bunch of apps in there, right? And they can do what they want. And we have an HPC ML, high performance computing machine learning situation. So the job, we have tons of GPUs. We just brought on a whole bunch of A100s, and so we have a lot of GPU jobs in our Kubernetes cluster, and that stuff runs, and it, you know, crunches numbers and gives us back the data and all that stuff. So in fact, we're going to see a lot more Kubernetes being used to do this kind of thing, high performance machine learning, because it really helps well to orchestrate when things go bad. And frankly, when you're dealing with machine learning, you're dealing with jobs that can go bad really easily because they are really pushing the limits of what your GPUs can do. They're right up there on the border, right? So you wouldn't want that kind of stuff not constrained in some way. You just threw it on the server in old school style without any constraints whatsoever. Those jobs would blow away everybody else. Imagine running a machine learning job. I mean, if you want a justification for containers, period, just imagine in the traditional multi-user, multi-tenant, whatever you want to call it, user environment where you've got, you know, like the case, you know, Carnegie Mellon University server for Pico CTF comes to mind. It's a hacking game. They have over 32,000 system machine users on that system. And any number of them are logged in concurrently every once in a while. They're using a very old school traditional way. Now, everybody who learns in sees everybody else's IP. They're sharing resources with them. Everybody is sharing the same resources. So if one person writes like a password crunching, thing, all of a sudden it's going to spike. And, the system administration tasks of the 90s were, hey, go back and tell the so-and-so that they're killing everybody else. And so the promise of originally shrewded environments and then later, C groups and namespaces and all the stuff that led to Docker is that your work doesn't impact other people on the same system. And so that's the basis of containers. If you don't know, that's why that's such a big deal. But the reason I bring it up is because, Kubernetes API resources. Thanks for that command. Yeah, if you want to see all of the resources, let's go ahead and do it. Imaluba reminds me. That's anytime I do a K, it's kubectl API resources, and we see that I'm turned off right now. Yeah, I got to start my Minikube back up. Yeah, let me do this. Hopefully it won't take me down. See, I'm doing the ECK. This is Elasticsearch stack. So this brings us backward. Minikube is a tiny Kubernetes cluster environment that runs on your computer without much additional, problem. And mine is using the Docker driver, which means it puts the equivalent of a machine into one container, and each container kind of acts like a machine. It's not, but it kind of acts like a machine. And it takes a little bit longer for mine to come up because of it, because we're trying to emulate a high availability environment by having, an availability zone for each Docker container. That's what we were left off last Friday. But yeah, I have to fire this up before I can show you the command that Maluba just talked about in the chat. And it's like how to list all of the resources that are in your environment, which if you're reading old documentation, they used to call objects. Thank God they changed that. So API resources, there we go. So there's all of the API resources for the current cluster. You know what? I thought I had it so that it wouldn't wrap. Wait, what is? I thought I finally had it so that it wouldn't overcome. It is. Those little bastards. I went all the way to 95 columns and they're still wrapping on me. That makes me angry. Because I thought I increased it enough to do that. Anyway, so those are your. I can't go more than that. You won't be able to read it, right? I don't want to go more than that, or you won't be able to read it. Short names. Yeah, it makes it really hard to read, though. I'm sort of annoyed. I should do a selector and do short form or whatever. Okay. Anyway, those are all the things. So you have persistent volume claims. You have nodes. You have a namespace, limit range, an event, endpoint, config maps, bindings. So these are all. If you want a good, you know what? Let's do this. Let's use awk. It's like the only reason I ever use awk. I can probably do it with cut, but I never do. I know you can judge me if you want. This is the only thing I ever do with awk right now. I kid you not. When I want to cut out the first column, I just do it that way. So there we go. We got, binding. These are all the standard resources that come with the system. Pods. Why did it put it in plural though? I wonder. I remember everyone that ever sold Harry Potter. Oh, we don't want that one. We want the last one. 1, 2, 3, 4, 5. We want 5. Yeah, we want 5. Mike. We want 5. There we go. Oh, wow. So these are the main ones. Config point, endpoints live, namespace, no persistent volume claim, pod. There's actually more. Where's replica set? I don't see replica set here. Oh, here we go. I see. Fine. Let's do this. Let's do unique. How about that? Nope. That didn't work. Sort and then unique. There we go. And then grep-v kind. just because I'm being anal. All right, so here they are. So certificate signing requests, a component status, config map, cron job, daemon set, custom resource definition. So a custom resource definition, CRD, is a type, and this adds a new type, sort of a new kind, I guess, a new resource. Deployment endpoints, event ingress, limit range, namespace, network policy, node. The ones that you most usually use are replica set, pod, persistent volumes, nodes. I've never heard of pod distribution budget. I haven't heard of that one before. Deployment, I told you, daemon set and deployment. Deployment is hands down the one you use the most. At least I do. Namespace, network policy, persistent volume claim. That was interesting. Did we already cover that? Oh, no, we didn't. Pod, yeah. Wait, what? Storage class, stateful set. Stateful set's another one that's actually relatively new, I understand. Anyway, so that's the resources that I was mentioning. So when you get all of this stuff running in your cluster, what you do is inside of your huge cluster of applications on Kubernetes, you get clusters within the cluster of resources that go together to form a logical application. And so you might have a config map, and you have a deployment, and you have a job, or you have some RBAC rules or something like that. Actually, the RBAC is kind of cluster level. So basically, the scope within the cluster is identified by a namespace. And so you can picture like the big, huge cluster, and then inside of the cluster you have little clusters, and those little clusters represent applications for your users and applications for you as an infrastructure administrator. So for example, Elasticsearch. Elasticsearch is one of our system namespace applications. So we have a label that further groups them. You can kind of imagine sort of a dotted line around a number of other little namespaces, so that, you know, the larger group, a dotted line, would be all of our infrastructure stuff. And we're talking about, you know, Argo, and I mean, there's a number of applications. Twitch title isn't changed. What's up on my Twitch title? Oh God, I thought I changed the title. Oh, it's because I didn't change it. Sorry. Let me change it. So Kubernetes. Thank you. Kubernetes Colearning. I really apologize for that. I'm trying to get good, but it's because I forgot to do a cast at the beginning. Yeah. So there we go. Thank you for the reminder. So this is set theory all over again. It kind of is. So why do you care? Why do I care? Because we've decided, and it's actually pretty common practice, to label all of the namespace applications, to give them all a specific label so that we can keep track of them in the event that our whole cluster goes down. Now, there's lots of other backup methods we have, and I mean, that's not anything particular to these saved. We do keep kind of tabs on what names, all the stuff inside of that has the label, all of that stuff, how we keep track of it so that we can tell whether it's changed over time. To see if something snuck in, if somebody did an edit or something. It's kind of like a tripwire, you know, to tell whether your files have changed, right? So if somebody goes in and does like a live edit against one of our system namespaces temporarily, and it sticks, you can set it up to alert you that you've got to change. We just, there's lots of ways to do it. I won't say our specific way of doing it, but all you really have to do is just dump all of the YAML files for all the resources with a specific label, and then see if any of them have changed since the last time, and you can kind of watch all that. But the larger concept here is the concept of an infrastructure namespace, or a namespace that is under your management, that is sort of a part of what you do. In other words, if you have your at least in our case, the responsibility is to keep the cluster running, right? But we have a secondary responsibility to keep certain system applications running that are supported by our team. So some organizations might have that broken out into a separate team. They might have a team to just maintain the system infrastructure, but it doesn't make a lot of sense because a lot of these cron jobs and stuff are just reporting on, we have a lot of them, and I don't need to get into detail, but we have some that check on whether our users are within their namespace quotas. We have others that are checking, whether things are in compliance. We have stuff that's rotating logs. We have stuff that's, the Elasticsearch stuff. We have Argo. We have some of the standard. So like for example, there's an application called Node Feature Discovery, and if you don't know what that is, I can't more strongly recommend that you look at it. I actually installed that. It's one of my first tasks on this new team. It's a thing called Node Feature Discovery, and what it does is it adds a plethora of additional labels to every node, so that actually not just to every node, so that the people making jobs can be more precise in making a decision about where that job or that pod should run, whether it's a one-time job or recurring job, or it's an application service that's going to be running all the time. And that's pretty much most of the work, right? You're either got a one-time job that's going to finish and produce results, you got a service that's running all the time, that you're going to have an API to usually, or you have a cron job that's like regularly doing something. That's pretty much the only real substantial kinds of things that you have running in your environment. Those are the things that the type of things that run, and those have specific types, right? So job, cron job, and deployment, for the most part. And so when it comes to system things, for example, the reason I brought up the Node Feature Discovery application is because it was a Helm chart. And so most of this stuff, you can tell it's an application because it has a Helm chart. And so we installed the application for Node Feature Discovery, and we had to make some tweaks to it. We had to change the Helm chart. We had to add some things to the Helm chart so that it would set standard constraints. And that's where the OPA Gatekeeper stuff comes in, right? Because, running as root and or setting up CPU and RAM constraints, if you don't have those, if your application doesn't set those things, your application will run wild, and unless you have some other thing on top of that to kind of keep it in check, it won't do that. But the policy itself is supposed to be the thing that keeps that in check. So so Node Feature Discovery, how's it going, Hermeth? So Node Feature Discovery was added and through the Helm chart, and now has a label, that identifies it as being one of the applications that we maintain on our team. And if you wanted to subdivide your team, we kind of do that. There's no official definition of this subdivision on our team. Speaking of which, I need to make sure I'm looking at this. There is no official subdivision of our team for this stuff, but we have applications in our space, in our world, that do not have owners outside of our team. So our team, somebody, this is how it goes. Somebody from our internal customer base says, hey, I want this thing that does this, the Ray operator, Domino, Jupyter Hub, Argo, they have all of these systems that they want, and they want us to add. And so we do the job of adding it in and supporting it once we agree to it, because it's you're biting off on it. But then we have to create our own systems for maintaining and auditing our own systems that we've agreed to maintain. So that's where I'm at. The place we are right now is we bring new people onto the team, and there's some 25, 30 applications that have been installed that a newcomer would be like, well, what is this thing and what does it do? What is Node Feature Discovery? What is Jupyter? What is Domino? What is Argo? What is this, this custom made cron job that does namespace audits? What is, there's like, we have one of our jobs that it's not proprietary to tell you this. We have a job that checks all the user namespaces. It's not uncommon to have, in fact, it's probably at this point a best practice if you've got multiple users in your environment to have those user namespaces be pre-populated. When you add a user to Kubernetes, you usually are adding other labels and information to their user namespace that connect with their authentication and with their system settings, kind of like the entries in Etsy password. So, the old days in Etsy password, you would put things like, you put commas between them. It's like, hey, this is the class they're in, this is the level, this is their whatever. And then you assign them to certain permissions groups. And so that's so we have a job that just manages that. And that's very specific to our company. That's the kind of thing that you couldn't just say, oh, every company should have this, right? Yeah, I mean, you could kind of generically say, because we do have a one-to-one association with our Unix, NFS systems or GPFS, login stuff, and I don't want to give too many internal architecture details away, but I can say that there are applications that need to be managed, and they need to be audited, and they have to happen on your team, even though your primary responsibility is keeping the whole cluster running, expanding it, updating it, and everything. But your additional responsibilities include maintaining, expanding, and adding new ones, as well as maintaining and updating all of the system or infrastructure namespace applications, such as node feature discovery, et cetera, et cetera. So those things have to all be managed. And I've created a YAML file to keep all of those straight, because there's so many of them. Anybody looking at this, it's kind of the same problem you have without, it's, the problem you have if you don't put comments in your code. It's the same problem. It's exactly the same problem. It's like, by the time you add like the 30th different application, you're like, what was this application and why are we using it? Why did I add this function? And if you look at Kubernetes at a meta level, if you back away from it, kind of like backing away from our solar system and seeing the Earth as just one planet, right? If you back away from Kubernetes, when you look back down at it, Kubernetes is just an operating system. At the end of the day, it's an IT operating system, and all of the applications and code, and you can even consider all of those things to be, functions or bits of code that run together. So you can think of it in terms of software. If you're a software developer, it's one of the reasons I think it's so critical that everybody learn at least minimal coding and encapsulation and function, separation of concerns, all those things, because those ideas are a part of the IT infrastructure as well. So having a YAML file that documents every one of the functions, they're not functions, but applications, whatever, is super critical, because you don't even know where they are, let alone how they were deployed. And most, I've talked about this before, I don't want to get into too many details, but most enterprises have a way to deploy. Helm is supposed to help with this, and I was really shitting on Helm the other day, and the reason I was is because Helm completely ignores any kind of gatekeeper policy checks. It's not a part of what Helm does. Helm is designed to just maintain a set number of configurations and templates, and to put it in, to update it, and all that stuff. Kind of tries to like be RPM, but it's not. But as I talked about at length in another time, I really ranted on this. I hate Helm for lots of reasons, but one of the reasons I hate it the most is because it doesn't have any notion of gatekeeper policy. So one of the things what frequently will pop up in a system, which has been the case in our system, is homegrown installation tools that use Helm, and they encapsulate Helm and they use it, and they, in our case, they apply OPA Gatekeeper policies up front against what Helm would produce to see whether you've covered all the bases before we actually deploy this thing, whether it be dev or production. Not disappointed. So what I'm trying to tell you is that this idea of encapsulating, okay, and I mean, I'm going to mention something that's very controversial, and I don't have a strong opinion on this yet. This is up for debate, but the question is, what is the right thing to do? What is the best practice here? To stick with Helm, and after the fact, to use Helm, to use the tools as designed, or to supplement the tools with other tools that are homegrown that encapsulate those tools. And it's a huge debate. That's a huge sort of workflow debate, like team workflow debate. On the one hand, you have the people that would argue that you should simplify the installation process as much as possible through customizations, and that you should teach your current team and your new team your customizations because they simplify the process and make it easier to maintain. That's on the one side of the debate. And on the other side of the debate, you have people that say, if you build a custom tool, that's something else that everybody has to learn, and it will cause them to lose the skills of being able to use the actual industry tools directly. So let's take a scenario and talk about this, because I think this is open for debate. I would really love to hear the debate from our community on this, because on the one side, let's say you have a new person come into your team and they need to update node feature discovery. We'll use something that's public. Okay. So you have a new person come onto your team and they need to update node feature discovery. And they say, okay, how do I do it? And I say, well, and they already know Helm because they got their CCAD, they're certified, they know Helm, they know how to do it. They go say, where's the Helm chart? I'll just do the update. And I'm like, no, you can't do that. You got to learn our tool for doing the deployment. Like, well, why? Is it, well, because our tool checks out the OPA Gatekeeper policies and Helm doesn't have that. And they're like, oh, okay, well, let me learn it. So then you have to have all the documentation. They have to go learn it, and hopefully it works, right? Because it's homegrown, which means it doesn't have, as bad as Helm is, it has a huge community that's watching it, right? So unless you get some sort of business advantage by having your own tool to encapsulate Helm, the question is really, do you want to send that person through to learn all those things, right? So here's a separate approach, okay? So a separate approach would be, okay, you need to go update node feature discovery. Like, where's the Helm chart? Okay, here's the Helm chart. It's got, the Helm chart's got its own GitHub repo, and we're going to run the Helm chart from that repo. And awesome, I'm on it. And he does Helm repo, or her, they do all their things, and they completely update the Helm chart. And then after the fact, you come back and you realize that they deployed it to development, which has lighter weight gatekeeper policies, which let it go. And then they go to, which is bad practice by the way. Because it happens all the time though. People will turn off gatekeeper policies and stuff like that on dev in order to test things out and get it to work. And then, so you're in your dev environment, your dev production, your dev Kubernetes environment, and boom, you got all this stuff that's passing and it's upgrading and everything. And you say, yeah, it's all good to go. And you set a change ticket window and you go through and you deploy to production, and it all fails because the gatekeeper policies are stricter on production. It's not uncommon in my experience, very limited experience, for the gatekeeper policies to be different between clusters. They shouldn't be. I think they should be very strictly the same, and they should never vary, personally. Some people use in-memory databases in development too. Yeah. Yeah, I know. So there's a bunch of things that probably shouldn't happen, right? So then whose fault is it? Right? So the person goes and uses the Helm chart. They know Helm because it's a standard tool, whether you like it or not, it's a standard tool. They use Helm, they use the charts that are there, and they probably have to write a bash script, by the way. They probably have to write a bash script because there's usually something that has to happen. So you usually are not just running Helm. And so the question is, what's better? A single GitHub repo per application, which I happen to think is better, with a customized bash script that encapsulates the standard tools. So you have, the only things you have to deal with are bash, Helm, and whatever tool you use to check OPA Gatekeeper policy. And you write all of that in a script that's very readable. And then you expect your new people to be able to read bash. They need to be able to come in there and they need to be able to read the bash script and know what's happening. And then there's no extra application written in Go or some extremely, complicated bash code that they would have to decipher in addition to whatever it is it does. And they have to understand its entire framework. And that's kind of where people go with this. It's like an extra layer of abstraction with the intent of simplifying things, but it actually removes the developer from, it removes the administrator from the tools that they know. So I think I kind of tilted the scales here for everybody. At least I've kind of given you what I think here. I think that this covers this. If you have a tool that covers up the problems in Helm and people aren't using Helm, then you first of all, you have to train people in 2 or 3 tools, and secondly, they're not getting into that kind of thing. Yeah. So this is the kind of situation that you might find yourself in an enterprise environment with multiple people on your team, where you have to make a decision. And frankly, I think the decision in this case is to have a team that learns, rather than, okay, let's say you bring in a junior Kubernetes engineer, and all they know is Helm, which is be really weird, but I'm not going to say anything more, but there are people like this. There's people out there, let's say, who have minimal shell scripting skills, minimal, like almost non-existent. Their Python is good. They have no bash scripting skills, hardly at all. But they know Helm, and they know Helm templates. It's the strangest thing. And they know Kubernetes. Yeah. And that's it. So if you take that person and you say, oh, we wrote this script to do this. And by the way, there's some debate about what script you should write that in. I personally think it should be bash, because all you're really doing, you want the lightest layer of scripting on top of Helm and the OPA Gatekeeper policy script as possible. You want to stick with the Unix philosophy, right? And if you throw Python in there, you've like really fucked everything up, because now you've got another full layer of application to understand. So you're forcing your engineers to know Python and shell. And by the way, half of those lines of Python are just going to be calling out to the command line to call something else. So you should just use the shell script in the first place. And the thing I find difficult about this entire situation is that there's a decidedly pejorative attitude, pervading out there against shell scripts to do this stuff. And I think it's a false thing. I think it's bad. I think, people keep trying to clean things up and make it fun. There's a reason that Helm is good at pulling together those things. You know what I mean? There's a reason that Helm is there. I'm sorry, that Bash is there to do that. That's what it's meant to do. Bash is meant to pull together command line execution of other things. And so, in my opinion, deploying a Helm chart as a Bash script is the best way to do it. I think that's actually probably should be the industry standard way of doing it, because any divergence or extra thing that you have to do that's not included in the Helm chart is immediately visible to you as a kubectl command directly. So you can see it right there. It's not obfuscated away in some, organizational sort of thing. Now, this does get tricky though, because what happens when you have 2 or 3 or more environments? So let's say you have exactly the same Helm chart, and you want to deploy it to development, and you want to deploy it to production at the same time. Well, now your shell script's gotten a bit interesting, right? Because now it has to say, oh, I want to push this to production, right? Or I want to push this. I personally think the answer to that is to simply add another function to the script, or to have a sort of a context situation going on, where if it detects the context, it goes and changes it. Because you shouldn't have really significant differences between your production and development environments, period. If you do, you got bigger problems. And I personally would like to see those problems get escalated. Those are the kind of problems I want to see. I want to see that kind of stuff. So our team is kind of in agreement about this. In fact, I was sort of surprised to find out that several people on the team have no problem. In fact, they want to get rid of the extra layer of encapsulation on the whole system. And so I'm kind of exploring what that would look like. So, by the way, one way you know that you got a problem is when the people who built the system, or the people who built and used the system that encapsulates the Helm charts, don't use it. They just go straight to Helm, and they run Helm with -f, and they're good to go. And they bypass all the policy checks and everything, and now you're left with a thing that doesn't pass. And then when you're forced to go back to using the tool, you fail because your policies don't fill out. And then I actually had this problem. And then somebody else will say, no, it works just fine. I'm like, no, it doesn't. Not if you use the tool. And like, well, I didn't use the tool. Like, well, okay. You don't need to use the tool. You can just do this directly. Okay, well, what are we doing on this team? Are we using the tool or are we not using the tool? Because if I don't use the tool, I mean, we need to find out. This was the thing. This was the thing. So I don't want that to be a thing where you are. If you're watching this, if you're watching this, it was really rough because I was a beginner and they were making me feel really stupid. And they basically just threw the tool out and did whatever they wanted to with Helm and direct YAML edits. And then because I couldn't get the deploy to work through the proper tool, I was the idiot. At least that's how I felt. I don't believe anybody ever told me that or called me that or said anything like that. And then of course, it came out, kind of subtly in chat after that all the things that they had done to get it to work to bypass the tool. Use Argo to help with this. I think Argo might be able to help there. I don't know Argo enough to suggest that would be a suggestion, it would be a solution or not. I don't want to deploy a Helm chart with Argo though. I don't think that would be the way to go. I don't know. I honestly, the amount of customization in your Helm installs that has to happen, I think needs to remain with as close as possible to the Helm chart. And frankly, I personally believe that every single Helm deployment that you have in your enterprise should be its own Git repo, that you should avoid putting it in a monolith. And these are because if you break them out into separate GitHub repos, you can detect any changes that are there. You can write a README that's very specific to that application deployment. By the way, all of these practices I'm talking about, they equally apply to application namespaces that are not system and infrastructure namespaces. So this is all CCAD stuff, certified Kubernetes application developer stuff. And by the way, when you're making an application and you're making a Helm chart, you should probably think more that outside the boundaries of what's going to have to happen besides just the Helm chart, because you've also got to consider what you're going to tell people to do. kubectl and customize using Kubernetes manifest files in each microservice. We deploy all our apps via script using kubectl and customize. Do you do Docker? You do Docker Compose then, right? Boogie Bugs, are you using Docker Compose? You have no Helm? Yeah. You're just going straight from, you probably have Docker Compose files then, I'm guessing. Yeah. A lot of people hate Helm for that reason. That's why I'm wondering. So you have a Git repo. Boogie Bugs, let me understand what you're talking about there. So you have a Git repo per application, and you have a Docker file for your images, right? And then you probably, well, let's just talk about it for a second. And then you make a deployment. I'm going to try to understand it before I, say it's bad. And then, so then you just run your script and it does the deployment, right? I guess the problem, the one thing Helm does bring to the table is version management, right? So it allows you to step a thing forward or back or whatever. But I suppose you could do it with Git. You could just do it with Git, right? It's like we have a new version. We updated our version. The problems I have with not using Helm, I completely understand where you're coming from, Boogie Bugs. I hated Helm too. I would be right there with you. But the problems you have is the entire industry has decided, why is it bad? That's bad. Well, I'm kind of going to touch base on that. So the entire industry is moving towards Helm to deploy applications. So for example, to deploy Jupyter Hub right now, it's impossible for me to not use the Helm chart. So I can't, the fact is, I simply cannot do kubectl and customize to deploy Jupyter Hub using the standard Zero Jupyter Hub package as supported and maintained by the Jupyter Hub project. So in that specific case, there's no option for me to do that. I have to use Helm. And there are a number of other specific examples of that where in fact, it's so much of a standard these days, whether you like it or not, that it's now officially a part of the Kubernetes application developer certification if you are into those things. But the fact that the Cloud Native Foundation got behind it that much means that, there's something to it in terms of like deploying an application in a consistent way, in a way that the application developers intended. And given the complexity of Kubernetes applications, some of which have, dozens, if not hundreds, like, of different resources, you need to group those things together. I shy away from the word package because it's not really, it's just a collection of configuration files at the end of the day. But that to me doesn't qualify as a package. So you kind of have to have those things together. We use Helm for live stage dev environments at my last job, and it worked perfectly. Can I ask you a question about it? Did you stick with Helm by itself, and did you have any OPA Gatekeeper policy stuff in place when you did that? There are many ways to deploy apps to the Kubernetes cluster. There's many ways to deploy apps into the cluster, but there's the reason that Helm exists is because people who create applications want a consistent way to allow their users to install those applications. And right now they generally have three choices. Create, a homegrown set of scripts that do exactly what you're talking about. Then they just tell people just run the script. They create a controller, an operator. So like Ray operator or something like that does all the installation for them. And that's kind of an emerging way to do it. Or they use Helm charts, and Helm charts is a sort of a package manager. You do Helm install, and it basically goes through the template system, applies all the values, and then does a kubectl on everything for you. But it doesn't allow you to change some of the variables as you go through it. So those are the different things. Yeah, thanks for your input. Yeah, work rock solid. Yeah, you might have a deployment pipeline that works really fine for what you're doing for your microservices, but if it sounds to me, Boogie Bugs, that you don't have an enterprise demand for other applications that are packaged to be installed. So you probably, I would love to know. Have you been asked to deploy node feature discovery, for example? And you probably don't need that, right? So, and there's people who don't even need Kubernetes at all, and they can just use Nomad or something like that. So I don't mean to say this is the only way to do it. I'm just trying to get my head around the way that has been accepted by the Cloud Native Foundation to deploy applications, for better or worse. I didn't catch what I said. What I want to know is, do you have any OPA Gatekeeper? So G9 RGA. Do you have any OPA Gatekeeper? Do you do any of this checking before you do a Helm deploy? I'm trying to find the best practice for doing that. My feeling is that it's not happening. I actually think if I were going to do a talk at some point, I would talk about this step right here, because I don't think it's happening. I don't think enterprises are doing this in general. And I think the reason that there's rampant problems with security in the Kubernetes deployments is because the average new person to Kubernetes thinks there's a Helm chart. They read all about Helm deploy or Helm install, and they do it, and they never even consider for a second that they should have added a whole bunch of stuff to make their deployment safe. Stuff that's not discussed in the Helm chart, or that they overlooked in the Helm chart because the documentation for the Helm chart was so fucking long. I think these are real problems in the industry, and so you're hearing like talks and people bubble up and say, no, we need to start locking down, the security and privileges and constraints of our clusters. We need to start applying some policies here, and it's hard to do after the fact, And so I feel like there needs to be this step. This step needs to be there, but I don't want to obfuscate the step with a bunch of unnecessary complexity by building our own tool. Personally, it might be the only way. Who knows? So it would be nice if Helm integrated it. If there's one wish I have for the world, it would be that Helm itself would add a stage called verify policy or something like that. If Helm, and it's an open project, it's something I might actually participate in if I actually didn't think Helm was such a dumbass project. I mean, just go look at how they use makefiles. So, if I could actually work for the project without like, I mean, maybe they just shut up and like, go out there and make those changes myself. But I have a feeling I get shot down by people who think they know more, and that's fine because that's IT. Um, and they do probably know more than me on a lot of things. So check the Helm deploys for OPA Gatekeeper. If I could do Helm Validate and have it run through, but I actually don't think you need to do this. I think you can do Helm template and then run that through the OPA Gatekeeper stuff, and you're done. And I think you could make a pretty easy workflow for that does not require an additional tool. It would just require understanding about how to do it. So I actually want to do some of that right now. I'm going to take I'm going to take a break because I've been talking for an hour, and I'm going to take a 5 or 10 minute break, and I'll come back. In fact, I'm going to go ahead and stop this YouTube video right here. And I'm going to take a break. I'll be back. We're going to be going probably, because I was late today, we're probably going to be going until about 2 p.m. Let me change my schedule. I'll try to go for a run at 2. By then, maybe it'll be warmer, by the way. So let's do that. And then I will, I'm going to close up this session right now. But I'm going to add a new Kubernetes Colearning session. I'm going to go ahead and duplicate this one and put it on the calendar here, so you can see the changes here. I'm going to go ahead and duplicate this one. Duplicate Colearning. Yep. And let's change this one till today at, well, let's go ahead and save this one. Let's save this one. Let's put this one down. Why don't I take like 20 minutes or so? So what is that? What time is that? That'd be, is that 12:45? That's probably about time. So let's bump this down to 2:30, and then we'll go from 12:45 to whatever. There. Yeah. Okay. I don't want to go for a full another 2 hours. Let's go 90. I probably should break this up into 90-minute segments. Actually, it's kind of hard to do that much time. So yeah, let's do that. Let's go ahead and do that. And then I'll try to do my run. I'll just leave the run at 3. How's that? So if you're trying to follow along, so let's do that. Let's take a break. I'll have a little bit more lunch. You guys can take a break, and we'll come back, and I'll just be training at like 2:30 or something, and that'll be IRL. All right. Yeah, co-learning is just we're working on all this stuff together at the same time. So I'm not teaching you anything. If we're just kind of working through the stuff we have to learn and do as we do it. It's kind of co-working and co-learning at the same time. All right, so YouTubers, hang tight. Come on back, and you'll see the next video. Go ahead and follow the next one in the playlist.